Alright, ladies and gentlemen, back again with another fun-filled, action-packed, non-flipped Algebra 2 classroom video. Oh boy. Ruining my video, come on. Alright, so this is notes number 5 and it's vertex form of a quadratic function. So up until now, we've always graphed the function first, right? And then we found the attributes. We'd graph the function and then we'd find domain, range, all that stuff. But today, we're going to be able to find the vertex, axis of symmetry, minimum, maximum, and range of a quadratic function, all just by looking at an equation. We're not going to have to graph all of it, okay? So the good thing is, you already seen vertex form. It's not something new you have to learn. This equation, f of x equals a times x minus h squared plus k, that is vertex form. So, you know, we didn't tell you it's called vertex form, but that's the vertex form. We've been using it this whole time, okay? So remember how linear functions have a standard form, and then there's y equals mx plus b, slope-intercept form? Y equals mx plus b is the unique form for linear equations, just like vertex form is unique for quadratic functions, okay? So let's look down then. Okay, so this is called vertex form because you can find the vertex from this equation, okay? So take a look at these examples down here. There's 6 equations here, and it tells you the vertex on each of them. So I want you to take a look at them and see if you can find a pattern as to how they found the vertex for each equation, okay? So just take a second, look at those, and then see if you can see the pattern. Yeah. So, okay, now you guys might have seen a pattern. So using the variables or the letters from the vertex form, you see vertex forms up here, a times x minus h squared plus k. Using those variables, we can say that the vertex of a quadratic function would be at what? Using the variables. hk, that's right, h and k. Whoa. It's going to be at h and k. Because if you look at this first example right here, f of x equals x minus 5 squared plus 2, what's h right here? It's 5. Because originally the equation is x minus h, right? So h is 5. And then k would be 2, right? And so the vertex is hk, 5, 2. Just like that. But now I want you to notice something else. So look at the a value. A is the number on the outside of the parentheses, right? Yeah. Does a affect where the vertex was at? No, it doesn't. Because look at the bottom one down here. F of x equals 23 times x plus 3 quantity squared minus 1. That 23 didn't affect where my vertex was at all, right? So I want you to write right here, a does not affect where the vertex is at. Okay, so look at example 1 then. Let's do some examples. So right here they give you the vertex form equation, and all you have to do is find the vertex. So starting with the very first one, x minus 4 quantity squared plus 1. What's the vertex on that one? 4, 1, that's right. Okay, now just to highlight the difference, let's go to the third one where it says f of x equals negative 9 times x plus 7 squared plus 2. What's the vertex on that one? Negative 7, 2. Negative 7, 2, right. So you guys have figured out that inside the parentheses it's opposite, right? Yeah. Alright, good. So I want you to take a second and fill out the rest of them. Alright, let's check our answers. So for this middle one, f of x equals 4 times x minus 3 quantity squared minus 5. What's the vertex there? 3, comma negative 5. That's right. What about for the bottom left one right here?
5.
Negative 5, right? Because it's opposite of the inside the parentheses. And 0, right? Because there's no k value. So when it's missing, it's just 0, right? Because you don't have to write plus 0. That's pointless. Alright, what about f of x equals x squared? That's our parent function. 0, 0. And then last but not least, what about this one, x squared plus 3? 0, 3, right? Because there's nothing inside the parentheses. There's no parentheses, right? So that's 0. But it's got the k value, the plus 3 at the end, which is 3, right? 0, 3, good. Alright, next. Let's look down here at the bottom of the page. Axis of symmetry from the vertex. So real quick, guys, we're going to be able to find the axis of symmetry after we find the vertex, right? So what is the vertex here? What is the point that's the vertex? 2, 1, that's right. That's right here. That's the vertex. 2, 1. And what is the axis of symmetry?
X equals 2.
X equals 2, right? That's this line right here. X equals 2. And some of you guys may have noticed this already, but we didn't officially tell you. But the axis of symmetry, it always goes through the vertex. You see this? Because the vertex is the point that's right in the middle, right? And the axis of symmetry is that mirror line, which has to be in the middle. So the axis of symmetry is always going to go through the vertex, which means that your axis of symmetry, it always equals the x value of the vertex. You see that?
Yeah.
So the vertex is 2, 1. The x value of that vertex is 2. So your axis of symmetry is x equals 2, yeah.
What if like...
Okay.
I'm confusing myself.
So it's just like that. There's nothing crazy about this. So turn to the back page now. Turn to the back of the page now then. Look at example 2. They give you the vertex and they want you to tell what the axis of symmetry is. This should be very quick. What is the axis of symmetry on number 1? How do you write it? X equals 3, right, just like that. You just take the x value of the vertex and boom, that is your axis of symmetry. So what's your axis of symmetry on number 2?
3/4.
X equals 3/4, right. And then x equals 0 for number 3, exactly. Right, so that's not too bad. All right, now, also from the equation, we're going to be able to tell if the vertex is a maximum or it's a minimum, and we're going to be able to find the range of the entire graph just from the equation. We don't have to graph it, so watch this. First of all, on your papers, I think it says +2, right?
Yeah.
At the change your +2s to +3. Change your +2s to +3 on your paper, okay? Change the +2 to +3. Okay, so looking at this first equation, f of x equals 1/2 times x minus 2 quantity squared plus 3. Where's the vertex on that?
2, 3.
2, 3, that's right. Now, does the graph open up or does it open down?
Up.
It does open up, that's right. How do you know it opens up?
There's no negative in front of the parentheses.
Right, there's no negative sign outside of the parentheses. If there was a negative outside of the parentheses, right, in front of the negative, in front of the 1/2, then it would open down, but it opens up. So if the graph opens up, that means your graph generally looks like this, right? It's of this shape, which means your vertex would be down here, right? So if your graph opens up, that means your vertex is going to be a maximum or minimum? Minimum, that's right.
Minimum.
Do we spell min?
Yes, if you want. Alright, so now here's the part where you can just get the range after you find that out. If you know that the vertex is the minimum, then what is the range of your function?
Wait.
3.
What's the range?
3 negative infinity.
3 to what? To infinity, that's right. Because look, the vertex is the minimum, right? The vertex is the very lowest point. What's the y value of that vertex? It's 3. So the lowest y value is 3, but it goes up to infinity, right? It goes up forever. So we need a bracket and a parentheses. So looking at your second equation then, what's the vertex on the second equation? Change it to +3, remember? Yeah, it's 2, 3 again. We changed it to +3. Yes, this is also 2, 3. It's the exact same vertex. Bless you. All right, now does this graph open up or down? Down. How did you know that? Because of the negative sign in the very front, exactly.
Yes, sir.
And if it opens down, so your graph would look something like this, right? Exactly. Your vertex is going to be a maximum. Good. Now here's the important part. If the vertex is a maximum, what's your range going to be then? Negative infinity to 3, right? Because the lowest is negative infinity, and the highest point is 3, right, from that vertex. Good. And you need to use a bracket around the 3, right? Because it's actually touching that point. So let's do some examples then. Right here, on example 3, they want you to state the range given the vertex and whether the graph opens up or down. So on number 1, they tell you the vertex is at 3, -7, and the graph opens down. So if you can't, think of the answer right away, draw yourself a picture. If the graph opens down, it looks like this. The vertex is right here. So what's the range? -infinity to 7. Very good. To -7. All right. Now I want you guys to take a second and try number 2 and 3. All right. So let's make sure we all get the same thing. On number 2, what did you get for your range? Bracket 13. And then what? To infinity. Right. And if you wanted to check, it's because your graph opens up. It looks like this. Right, your vertex would be down here, so that's the lowest point at 13, and then it goes up to infinity. Right. What about number 3? What's your range on number 3? Right? -1/2 bracket. That's right. Good. Nice. So now we're just going to put it all together in example 4. It wants you to give the specified information based on just the vertex form of the equation of the quadratic function. So on number 1, what's the vertex of number 1? 3, -2. That's right. So if that's the vertex, what is the axis of symmetry? X equals 3, right. And does this graph open up or does it open down? Up. How do you know that? No negative sign on the very outside at the front, yeah. So it's going to be a what? Minimum, that's right. If it opens up, it looks like this. And that would be a minimum, right? Because the vertex is down here. So what is the domain? The domain is, as Aiden said, -infinity to positive infinity. Remember, the domain's always the same on quadratics. Yes, it's always the same. All right, domain's left and right, and quadratics do not stop in either direction, okay?
So the range will be bracket -2 infinity?
The range is going to be, that is correct, but my screen's not sliding down, so hang on a second. There we go, yep. So what'd you say it's going to be? Brackets -2. Stop it. To infinity, that's right. Oy. Okay, so that's one of them. And let's just do the other example to make sure. So, what is the vertex on number 2? -5. -1/2, that's right. And then what's the axis of symmetry then? X equals -5, right? Does this graph open up or down? Down. How'd you know? Negative sign where? Outside the parentheses, good. And what about the vertex? Is it a max or a min? Max. Because if it opens down, it looks like this. And the vertex would be up here. What's the domain? That's right. Domain's always the same. And then finally, what is the range then? -infinity. There we go, yeah. Because you can see on your little diagram, right? The lowest point is down here to a -infinity. The highest point is -1/2 at the vertex. That's right. And that's it, guys. Pretty short and sweet. So until next time, see ya. Peace.